All right, so now we're doing Chebyshev's theorem, and Chebyshev's theorem says that the proportion of values from a data set that will fall within k standard deviations of the mean will be at least 1 minus 1 over k squared, where k is a number greater than 1, and this is a percentage. So we usually calculate this as a percentage. So let's do some examples to see what this means, and then we'll finish up with empirical rule. So the first thing that we want to look at is, let me catch up here. The first thing that we want to look at is what if k, the number of standard deviations away from the mean, is equal to 2. So we're talking about the proportion of values of data that fall within 2 standard deviations of the mean. So in that case, what we have is, so we want 2 standard deviations from the mean. We want to know the proportion of data that lands 2 standard deviations away from the mean. So we're going to go 1 minus 1 over k is now 2, and we're squaring that. So 1 minus 1 over 4, or 3/4, which is equal to 0.75. So as a percentage, that says 75% of the data falls within 2 standard deviations of the mean. Okay. So now we're going to look at another problem that does a slightly different thing. So this is trials in a maze. So the average number of trials in a maze that a sample takes. So trials in a maze, let me write this down. So the average number of trials a sample of mice took to traverse a maze was 12. So the average number of trials a sample of mice took to traverse a maze was 12, with a standard deviation equal to 3. So use Chebyshev's theorem to find the minimum percent of data that falls in the 4 to 20 range. So what we got to figure out is if the average is 12, how many standard deviations is 4 to 20? So if I put 12 right smack in the middle, how many standard deviations have to move to get to 20 or to 4? So let's find, let's write down what we have. We have x bar is equal to 12, and sample standard deviation is equal to 3. And we want to find the percent of data that falls in the 4 to 20 range. Well, first we have to find, so if I look at this kind of like on a number line, and here's 12 in the middle, and here's 4, and here's 20, notice that 12 lies right smack in between, so that there's an 8 difference between both of those. So I could find that by going 12, I'm just trying to move that out of the way. 12 minus 4 equals 8, or 20 minus 12 will equal 8 also. Now, so that's 8 data points away from the middle, but I need to know how many standard deviations is that. So 8, the number k, which is the number of standard deviations, is the number of data points divided by one standard deviation, which is 3. And so that's 2.67 standard deviations away from the mean. All right, so that's my k value. That's what we just found, is the k value. How far away from the mean are these endpoints of these ranges? And so now if we want to find the percentage of data that lies between these ranges, we go 1 minus 1 over our k value, which is 2.67, and then we got to square that k value. So if we figure this out, you stick this in your calculator, I get 0.859, and I want to write that as a percentage. So I take the decimal, move it over 2, so I get 85.9, or approximately 86% of the data lies within 2.67 standard deviations away from the mean, or lies in that range from 4 to 20. Okay. So the last thing that we're covering in this section has to do with this graph that I moved. So let's move it up. And it's called empirical or normal rule. Or the normal rule. And it basically says that if you have a nice symmetric bell-shaped curve, this thing is referred to as a normal curve of your data, then, let me make this picture bigger. See if I can. Okay. Then if we go one standard deviation away from the mean, that's this portion right here, then that one standard deviation from the mean will pick up 68% of your data. If you go 2 standard deviations away from the mean, that's right here, 2 standard deviations from the mean will pick up 95% of your data, and 3 standard deviations away from the mean will pick up 99.7% of the data. So if you can figure out how to find how many standard deviations away from the mean you are in a normal or symmetric distribution, then you're going to be able to figure out what percentage of the data lies within those intervals. All right, so that's the last of this section, and if you need help with the homework, just let me know. So again, in this last section, we did Chebyshev's theorem and empirical normal rule.